Hello everyone, I'm Daigo Hayashi of ICD Love, Tohoku University, Japan. It is a great honor to be able to speak to you today. Today I'd like to talk about the redirection technique using jumping motion. This is what we're doing with HIT Lab New Zealand. Redirected walking techniques are a well-known method to address problem of limited tracking space. With these techniques, the user's walking distance and direction are imperceptibly manipulated to enable them to explore much larger spaces of the VE than the physical space. A lot of studies of redirection techniques have been done, but most of them are explored in walking and its accompanying movements. For the more compelling and immersive experiences with full body movements, it is quite necessary to examine redirection of more intense motions in addition to walking. Here, we focus on jumping, and we propose redirected jumping, a new redirection technique for jumping motions. Jumping is used in various situations, especially like games and sports. And also, it is one of the most popular motions in everyday life. In general, jumping motion causes larger head shake than walking. It should have high potential for glider gain manipulation than existing redirection methods. Next, jumping is a popular motion used in various situations, but have not been explored enough. Adding jump motion to existing walking-based experiences can enrich users' body movement experiences in VR. So we believe redirected jumping provides larger workspace in VR and better experiences to users. This related work proposed a technique simulated scale jumping in gravity-reduced environments like on the moon by using cable-driven system. This work is quite related to ours, but only investigates simulated jumping height in special situations that recreate reduced gravity environment, and it needs large external devices. So we set the requirements of redirected jumping to realize the richer jumping experiences. Firstly, the system should work without any large control devices. Secondly, the physical jumping actions should be easily done by everyone. Lastly, jumps should be done repeatedly in the standard physical tracking area for safety and applicability. In many types of jumping, we chose the 3 types of the most basic jumping actions and investigated the manipulations of their physical parameters such as distance in the horizontal jump, height in vertical jump, and rotation angle in a spin jump with 2-legged takeoff and landing. Firstly, for manipulating a simulated jump, it is necessary to detect the user's jumping action. From our preliminary observations of the jumping actions with both legs, we defined the 5 states of the user and also defined both ascending and descending states as jumping. In our implementation, we used the HTC Vive, the VR system, and detected the jumping state by the positions of trackers attached on head, waist, and feet. Next, I'll talk about the detail of the redirected jumping techniques. We firstly consider distance relocation in forward jumps. When the system detects a user jump, the user experiences manipulated jumping distance with the gain for distance relocation in VR. When the gain is applied to a horizontal jumping distance in physical space, the user's point of view in VR moves further or shorter by the gain. We secondly propose the height relocation in vertical jumps. Similar to the distance relocation technique, the jumping height of the user in VR becomes higher or lower than revealed by the gain. Finally, we propose a redirection of rotation angle in the spin jump. This manipulates the yaw angle of the user jump. To know how much these techniques can be imperceptibly presented, we conducted 3 experiments of each method. This video shows the basic procedures of the 3 experiments. We employed a 2 alternative first choice method following previous research methods estimating perception range and redirected walking. The participants were asked to jump a fixed distance, height, or rotation angle under the game. After jumping, they judged whether the simulated jump was larger or smaller than their actual jump. Okay, next. We got responses to calculate the mean probability of the larger replies at each presented game. The game with which the participants answered larger in half of the trials is taken as a point of subjective equality. And in addition, we defined the detection thresholds for the game at which the participants reply larger in 25% and 75% of the trials. The range of the game between them means they can manipulate jumping without participants noticing. This slide shows the result of distance relocation method. The PSE was 1.06, and it indicates that the participants overestimate their jumping distance in the real world. The DTs were 0.68 and 1.44. It means that the jumping distance can be changed without noticing by the gains between them. And next is about height relocation. The PSE was 1.12. It also indicates that participants overestimate their jumping height in the real world. The imperceptible gain range is from 0.09 and 2.16. It is very wider than the other results. Last one is about rotation reorientation. The PSE was 0.694. It indicates that participants underestimate their spin angle in the real world. The DTs were 0.5 and 1.39. This table shows the detection thresholds on the point of subjective equality of the manipulation gain obtained from the 3 experiments. Here, for discussion, I also show the result of the previous research about redirected walking perception. First, the wider ranges of the imperceptible gain than walking means redirected jumping can reduce the size of physical workspace by adding more jumping opportunities into ordinary walk-through experiences. We think that large head shake and short flight time to judge cause this wider gain range. In experiment, most participants had low confidence of their answers. Second, the imperceptible gain range of the height was much wider than the others. In this experiment, participants asked to jump up about 0.2 meters, so manipulated height might be too small to judge. Third, our results shows differences of the PSEs among the 3 types of jumping. This knowledge is useful to provide users more natural and safe jumping experiences in VR by using the gains properly. Even though we explore the possibilities of our technique, our work remains only a first step in achieving unrestricted jumping experiments in VR. First, this study focused on the 3 basic jumps with 2-legged takeoff and landing. Many kinds of jumps consist of the combinations of these 3, and maybe similar results would be reached by combining them. However, the investigation of other kinds of jumps would increase available scenes much more. Second, we need to discuss the generalizability of the result. For example, in this study, we used a simple virtual environment, but we have to test their sensitivity changes in the more complex VE as suggested by a previous study. Third, this study investigated range was where the manipulations were imperceptible and not uncomfortable. In redirected walking, even if the gain is large enough to perceive the manipulation, the users do not always feel discomfort or less immersion. We believe that this finding can be applied to ours and expand the possibility of the applications. This is the end of my presentation. Thank you.
Okay, Bobby.
Hi, Bobby Bodenheimer, Vanderbilt University. Nice talk. One of the things that I would be worried about in this talk, besides the things that you talked about, would be that when I landed, particularly if I had a self-avatar, that the HMD is going to slide, the trackers are going to jiggle, and my self-avatar is going to jiggle, and I'm going to get a noticeable effect from that. Aside from the fact of the noticeability of the redirection, that kind of noticeability is going to occur. Could you address that for a minute, please? Do you understand my question?
Maybe. You mean the effect?
The trackers are going to go,
effect of
and the HMD is going to go like that.
Yeah.
Okay? On landing and the jump. And that's going to cause problems aside from the fact of the redirection, right?
Right.
Okay, that's my question.
So, in our experiment, we tightened the HMD and trackers. So, the shake is almost nothing, less. But some of the users, some of the participants answered the interviews as that the shake is the shaking is affected the judges of their judges. So maybe we think it is. Of course, we think the one of the problem, and we think. What you said is one of our problems, and so it is the we will approach as we will approach that as a future works. Yeah.
Okay, so Evan, quick question.
Okay, I had a two-part question, but I'll try to be quick. The first question is, have you tried? Do you think that the perception of these techniques, the detectability, would change if you were jumping over a really tall obstacle or a deep pit? And then the second part of this is, even if it is detectable, have you tried ramping this up really, really high and giving someone superpowers, and how did that feel?
Okay, so the first question is changing the height.
If you had to jump over like a hurdle or over a big pit, do you think that the detectability of the manipulation would change if it wasn't just a flat surface you were jumping over?
And so
if it looked possible and then you did it.
Okay, so first question,
like a pit, there's an empty pit and I'm jumping over it. Do you think I would notice more?
Yeah, and we think maybe it's possible to changing the height, like step up the boxes, like something to do that. Okay. So about the detection slashes, about that, and sorry, let's discuss it later.
Okay, yeah, let's talk offline.
Sorry.
Yeah, I had questions too, but I'm going to hold them. This is so cool. Thank you.
Thank you.